Hello, welcome to a quick overview of ConceptX, an end-to-end framework for latent concept analysis in pre-trained language models. The fundamental problem this framework aims to solve is to reduce the opacity of black box models and understand how and why they work. The core idea is to surface latent concepts that are being learned by these models in their internal representations and then provide an easy and effective way to introduce a human in the loop to label these concepts. The framework consists of two steps. The first step is pre-processing, which extracts the latent concepts by means of clustering, and the second step involves a human in the loop and is the annotation itself. Let us now look at each of these steps in some more detail. The pre-processing step first extracts features for a given corpus and then runs hierarchical clustering on the contextual embeddings to extract latent concepts learned by that model. Let's take a quick tangent and understand what we mean by latent concepts exactly over here. A concept is just a set of words that together hold some meaning. For example, here is a set of words that all begin with the prefix un. Or we can also have a concept representing words that are abbreviations. Another example of a concept that is not necessarily lexical is a group of superlative adjectives. Here, this concept highlights a morphological similarity. Similarly, we can also have concepts from existing human ontologies such as LIWC or WordNet. In this case, all of these tokens belong to the body tag inside the LIWC dataset. However, the way humans have categorized tokens might be very different than how language models organize their internal knowledge. Specifically, many human tag sets and ontologies like part-of-speech tags, semantic tags, LIWC, or WordNet may group words differently than how these models group words. This is what we found in our analysis, where models actually learn much more fine-grained concepts. For example, the pre-trained BERT model learns to distinguish between birds and land animals, while most ontologies would categorize all of these in a single bucket. Similarly, we also found that BERT actually separates between Muslim and Hindu names, specifically in their own cluster. While this in and itself is not problematic, it can be a hint of a potential bias that the model may be using while making predictions, especially if the presence of a name in one of these categories results in a change in prediction when the religion itself is not important for a given task. We've also seen fine-tuned models learn task-specific concepts that directly relate to the task at hand. Examples shown here are positive adjectives in the case of a sentiment classification problem, and racial slurs in the case of a hate speech detection model. In any case, once we have the latent concepts from the pre-processing, we can begin the annotation process by introducing a human in the loop. The human is shown the concept itself as a word cloud, where they can hover over any word to look at it in context. Basically, taking your mouse over any of the words presents the top 5 sentences that appear in the corpus with that word in that specific context. One can also click on each word to launch a Google search in the case that the annotator is not familiar with the tokens that are being presented. The annotator is then asked if this cluster represents a meaningful concept, with the labeling field allowing for a quick auto-completion based on all past contributions. The annotation platform also shows the neighboring cluster in the presentation space to identify if both clusters represent the same or similar concepts. For example, the Hindu-Muslim name concepts we saw before were actually neighboring clusters in the space of BERT. And one can use this annotation to combine them in a hierarchy where both belong to a broader name concept. Maintaining such a hierarchy can be a very useful resource in analysis, since it allows us to understand concepts learned by a model at varying levels, from broad groupings to very fine-grained knowledge. Since some of the concepts do align with human ontologies and tag sets, we can make the annotation process easier by making use of the existing linguistic knowledge. We essentially use some pre-trained taggers to do auto-labeling, such as automatically annotating concepts representing specific part-of-speech tags, syntactic tags, etc. Some trivial auto-labeling is also done, such as labeling concepts containing specific prefixes or suffixes, or containing tokens from a very specific position within sentences. All of this is to make the annotation process easier for the human and to facilitate them in making good annotations. These automatic annotations are presented right below the annotation input and so are easily accessible to the annotator. Having seen the ConceptX framework, let us now see some use cases where this tool has been used and has been very helpful. The BERT ConceptNet is a dataset that used the ConceptX framework for its creation. The framework allowed for very fine-grained hierarchical labeling of the latent concepts learned by BERT and helped in its subsequent analysis. Thank you for listening, and we hope ConceptX is a useful tool in your journey of analyzing and understanding your deep NLP models.